Hello and welcome. I'm Chris Overholt. I work with Algorithmia as a sales and solution engineer. And today I wanted to walk through some of the key points to help you operationalize your machine learning lifecycle and how Algorithmia can help you move from data science development to deployment. So what I'll be talking about today is first I'll start with some of the challenges that we see in the machine learning space, especially in deployment and getting a return of investment on machine learning models that your data science team is working on. And I'll talk a little bit about how Algorithmia solves the ML production problem, specifically how we bring together three groups across different organizations to be able to give your machine learning models value to certain lines of business or downstream applications that want to consume the results of this ML work. And I'll describe where Algorithmia fits into your machine learning pipeline, and hopefully you'll get a good idea of what the data science workflow looks like and what the important handoff points are for getting a model into Algorithmia. And then we'll walk through some example use cases, right? So these are all things that our customers run through in terms of being able to deploy machine learning models faster to production, getting things tied into and integrated with your version control systems, your CI/CD workflows, basically getting machine learning to the point where it's tied into your software development lifecycle and lets your data science team iterate quickly and have that consumed by downstream applications. And we'll wrap up with some of the benefits that our customers are seeing by getting Algorithmia in as a central model catalog and model operations platform in their organization. So I'll start with what is Algorithmia? And we start with the challenges that many of our customers are facing in ML operations and management, right? So there's a couple of different statistics at the bottom here from industry reports. The first one is about how many projects really make it from a proof of concept into production, such that they're being used and consumed in a way that's giving back value to the business. So we see 85% of ML projects fail to make it past the POC stage. The second thing that we see over and over is that the time to production on average is about 18 months. This is a very long time. This is due to a number of different compounding factors shown here. Things get stuck in the lab. There's no real process to move towards production and get through all of the compliance and test stages that are necessary. Also, there's disconnected teams. So you have different data science teams, MLOps teams, and infrastructure teams trying to figure out, who's going to take care of which parts of the pipeline. Technology mismatches, right? So you have data scientists using a certain kind of framework, and they're not able to plug that into the operational framework to deploy that to production. Stakeholder buy-in, hidden technical debt. These are all reasons of why these numbers are what they are, and it really leads to an inefficient machine learning lifecycle and actually getting value out of your ML work. So if you consider the different groups or personas that are involved in this problem, there's really three key groups that we work with and bring together. The first one is the data scientists that are actually doing the model development work, building and testing models, and they're looking to move them towards production and have them used by downstream people or consumers. The middle group is the application developers. These are application developers running mobile apps or websites or integrating some of this work into dashboards and reports. So we want to help them understand how they can interact with the results of the ML models in a way they're familiar with. And then finally is the operations team, right? So this team is making sure that all of these services are up and running, that everything's performing as expected for these production line models. So you can think of Algorithmia as a platform for ML operations and management. And it's a centralized model catalog that really focuses on three main areas. The first is deployment. So we want to help you connect to your trained models, your training data, catalog all of those algorithms, help you with versioning, and ultimately help you validate when a model is ready for production and how it can be consumed. The second part is around operations. So we want to help you manage the cost and infrastructure in a way that the infrastructure is working for you, it's scaling up and scaling down automatically based on demand and consumption, and then you're able to get out logs and reports about how the platform is actually being used and which models are the most valuable. You can deal with chargebacks to organizations, so we'll talk about that a little bit later. And finally, we focus strongly on governance and security. So our platform is built from the ground up to focus on things like auditing, access control, and making sure that models are not only running in a performant way, but in a way that matches to and maps to your existing compliance and auditing processes. So let's talk about the Algorithmia workflow and give you a better idea of where we fit in as a solution to what most of our customers are doing today. So on the left side of this diagram are a lot of different model development and deployment frameworks. So these are things like TensorFlow, PyTorch. This could be in a number of different languages. Algorithmia supports 7 different languages: Python, R, Java, Scala, and others, in terms of what's actually powering my algorithm. So most of the training work that's going on the left side, we don't want to prescribe which framework should be used, which algorithm to be used, and those could be different training systems. That could be happening on a laptop for a data scientist, or that could be happening on a central development server with GPUs. We don't really care what's going on the training side. In fact, that should be divergent. That should be different platforms for different teams using the best tool for the job. Where we come in is on the right side of this, when you're looking to converge and move these models toward production, right? So Algorithmia here is basically taking a trained model from the left side and serving that in production, handling the deployment, operations, and governance and security, so the data scientists don't have to. So if you think about that split between what's going on in development and what's going on in deployment, Algorithmia fits in where there are things happening upstream, like data ETL pipelines, featureizations, and storing those in a feature store. And ultimately, a data scientist is going to be training a model on a certain framework, on a certain platform. Once they've saved and serialized the trained model, that's where Algorithmia comes in. You can think of it like a reusable model deployment pipeline that's handling your model catalog, versioning, pipelining, and all the other things shown here, so that the consuming applications on the right side can basically interact with these ML models through a REST API without having to worry about Python dependencies or system packages or versions or things like that. So this is the pipeline of where Algorithmia fits in. And as you think about the production process and what's going on, you sort of go through these different stages, and Algorithmia has a very long list of functionality and capability that we're giving here around model registration, pipelining, and model management that ultimately you get from day one, and your data scientists can reuse for all of the work across different teams, all while this is happening on a governed and secured platform. So if you walk through the actual stages of what is a data scientist doing, how does something move towards production, and then what's happening with the application developer, when we walk through some of the examples in a minute, this will be more clear. But on the left side, the data scientist is training their model, maybe using Python or R. When they get into Algorithmia in the middle here, we're basically saying, load your trained model. That can be from hosted data storage or external data sources like S3, Azure Blob Storage, Google Cloud Storage. Then there's the development environment. Thing in Algorithmia is a Git repository. So you can either work with a built-in editor or clone the repository, work in your own development environment. At that point, there's basically 2 steps to be able to make a version of a model available that can be called by a consuming application. There's a build step, which is going to containerize everything in the model, dependencies, and then there's the publish, which is going to make that model available as a REST API. And of course, that's going to get deployed as a Docker container to Kubernetes. All of this is happening as part of the Algorithmia platform. So really, the data scientist is just loading their model, building, and publishing, and we're handling all of the operational details on the back end, so the data scientist can focus on the model itself. And then on the right side are the consuming applications, right? So this might be a front-end application, visualization, a batch job that are actually consuming these applications. And we have 14 different language clients to actually be able to consume some of this ML work downstream. So let's talk a little bit now about example use cases, and I'll show you a little bit of these concepts in action. So the first thing, just to nail down some of the concepts in Algorithmia, this is Algorithmia platform. I've logged in as my user, Chris, here, and this platform would be installed behind your firewall, behind your VPC, either in the cloud or on premises. And if I go in here, I can see a few key areas. One of them is the algorithms themselves. So you can think of this as your model catalog, and all of these different algorithms would have been published by data scientists or algorithm developers at your organization. There's different categories here that can be customized to your whatever types of models your organization is producing. So I could go into the computer vision category, immediately see all the models here that can be called by a downstream application or even integrated into one of my own pipelines, right? So we'll go through an example later where we add an OCR model to an existing pipeline. So other concepts here include data sources. There are a couple of ways you can think about this. Algorithmia has hosted data collections, which means the data actually lives in Algorithmia. So I could put this is a useful thing to put my trained model into, or some of my training data, or any information I want to carry through from development into Algorithmia. I can host it in the platform itself, or I can connect to Google Cloud or MLOps APIs with in any of our language clients. And I could put in my Amazon credentials here, restrict this to a particular bucket. And that means I can reuse these connectors in my algorithm without having to manually copy and paste the connector code over and over. So that's data sources. A couple of other useful concepts and building blocks are organizations. So many of our customers use organizations to bin algorithms by team or by project or by external customer. So this is a good way to have developers or organization admins that can actually publish. They're the ones that are able to publish these models across the cluster. And it's a good way to isolate work. So teams should only really be seeing the models that we're working with within those organizations. And the other piece here around security and governance is API keys. So I can go in and create a new API key. I could scope this API key to only be able to call models in a particular organization or even a specific model or a version of a model, and then select what data access it has from the API keys perspective, and scope this to how it can be used. So this is a nice way to generate API keys that might be embedded in consuming applications and scoped to a very particular purpose, or embedded in a batch job, or things like that. So with those building blocks in mind, let's talk about the deployment process and what that looks like. So let's say that I'm a data scientist. I've just trained a model that deals with credit card approvals, and I want to figure out what to do next so that I can this model available to other people to call and consume in one of our front-end web applications that lets customers apply for a credit. So the first part of this is most of this work happens in the context of things like a Jupyter notebook, right? So if I go into a Jupyter notebook, this could also be in our Markdown notebook in our studio. This could be a Python script. So again, we're on the left side of the diagram I showed earlier, where we're doing our development and training work, right? So I'll run through this. This is basically all happening upstream of Algorithmia. And here we're going to use scikit-learn to train a gradient boosting classifier on some credit card data. And this credit card data basically says for a given customer and a given demographic, what is the risk score? We can use that to say whether we're going to approve them for a credit card and give them associated risk score at that time. So I'll go through this. We load the data, split into test and training. Here's where we actually train the gradient boosting classifier. And then once that's all done, we generate some test predictions for someone with a low risk and a high risk. So the model looks like it's performing well. This is typically the part of the data science workflow where we ask the question, now what should I do next, right? So I have a notebook, it has a trained model. How do I actually make this useful to downstream people or downstream lines of business, downstream applications, so they can actually consume this model either in batch or even better as part of a real-time scoring application, right? So at the bottom of this, what we're going to do is, and again, this could be done in a Jupyter notebook, in VS Code, basically any development environment that you're coming from the training side, the question is, how are we going to save our model in a way that Algorithmia can load it and serve predictions from that saved model? So what we're going to do here is save this model with joblib. We're going to save the trained scikit-learn model, and then we're going to upload it into Algorithmia's hosted data collection that lives inside of a particular organization. You could also save this to Amazon S3, Azure Blob Storage, and then load it from there in Algorithmia. Those are also valid options. So once we've saved and uploaded the model, we can go over to Algorithmia, and I'll show you what a model that's actually loading that in looks like. So I'll go into this organization. You can see a bunch of different algorithms here. This is our credit card approval algorithm. So if I click on that, we'll look into what's going on here. So at this point, we would have created a new algorithm in Algorithmia. You can, at that time, choose what language is powering the algorithm, if it's Python, R, Java, Scala, and we create a boilerplate sort of template that says this is how this algorithm works. So I filled that in here, and if I zoom in, you can see this algorithm is doing two things. It is first loading the trained model that we saved earlier, so the save scikit-learn model. The second thing that it's doing is inside of this apply function. So this apply function is important. This prescribes how we're going to handle inputs, how we process them, and then down here you can see where we actually generate a prediction from the trained model, and then we return output. So here we're going to return two things: the risk score for a customer between 0 and 1, where 0 is low risk, 1 is high risk, and then we're going to return a binary flag whether the customer has been approved for that credit card. So a 0 means no, and a 1 means yes, they've been approved. So that's what's going on. This is the calling function in Algorithmia, and this is, again, where we're getting what we've done in training and turning this into a productionized API. So whenever I hit build and publish here, that's actually going to make this available as a container. We're going to serve up that container. We're going to handle that whole process. And the end result of that is going to be an algorithm like this that can actually be called and consumed downstream, right? So let's look at what's going on in this algorithm profile for a particular algorithm. So we have the name, credit card approval, a description of what it's doing, some tags that help with this discoverability and catalog that we talked about earlier. And this image here is in fact coming from the documentation tab. This is just pulling from the README in the Git repository. So it's a good place to document what are the inputs, what are the outputs, how was this model trained. Here's a plot of the feature importance when it was trained. This is a great way to carry information from what was done in training in terms of hyperparameters and settings and bring that close to where the algorithm's actually running. If we go back to the profile page, about halfway down, there is a test console. So this is a place where I can put in some parameters. So in this case, demographic information, click run exam, I back my risk score. So this is a low risk customer and their credit card application was approved. When I hit run here, Algorithmia is actually querying this particular version of this model, spinning up the container, hitting it with my API key. All that's going on behind the scenes. So you don't really have to worry about the runtime, the consumption, the dependencies. You're just worrying about inputs and outputs from this particular algorithm. And in fact, we go so far as to handle this auto scaling. So if a particular version of this algorithm is getting, starts to get a lot of traffic, like 100 requests per second, we'll actually scale up the containers vertically or even spin up CPU and GPU workers horizontally to match that demand. And once the demand goes back down, we'll shrink those resources back down. So all of the versions of this algorithm are available, but they're not always running unless they're actually being called and consumed. The bottom part here is a good point to talk about. Now that we've deployed the algorithm, how is it actually going to get consumed in a downstream application? So these are the 14 language snippets that I referred to earlier. So one way to think of this is to say, if I need to retrieve some predict model in a Python application, a Streamlit app, I can do that with a Python language snippet and client library, and I can copy this language snippet. It includes the sample input, my API key, the model that I'm going to call and a specific version of the model that I'm going to call. I could do the same in R with a Shiny app using the Algorithmia package. Or if I needed to hand this off to a Java team or a .NET team because they have a batch scoring application, they could implement these code snippets in that application. The one that I'm going to show is if we have a customer-facing application and a web front-end team. So those teams might work in JavaScript or PHP in this case. So I'm at the point where I'm a data scientist, I've published my algorithm, and I want to hand this off to an application developer for a PHP web app and say, here's the code you use to call my model and make your scoring predictions and actually render that on the customer website. So to do that, you would copy out this PHP code snippet, and you could put that right into your PHP application, right? So this is some kind of boilerplate PHP application, and you can see here is where we've injected this code to actually use an API key, call a model in Algorithmia and a specific version. And this is also a good point where the application development team could do A/B testing or a gradual rollout, blue-green deployment. However they do that, they can use this version specifier to keep things in the old version of the model working while they're rolling out the newer version. And if we look at that PHP example, this is what it looks like. So this application, when it loads, is running the PHP, it's getting executed, and that code snippet's getting called. So it's calling Algorithmia with inputs. Maybe the customer filled out a form, and it's giving back immediately a real-time prediction to say, yes, you're approved for a credit card with a low risk score, right? These might be things that you store internally in a database. But we're just showing them here to show PHP application calling Algorithmia. This is how easy it is to hand that off to a team like that to be able to integrate machine learning in those types of applications. Another use case I wanted to talk about is around pipelining and model pipelining. So if I go into our organization, the model that I just showed was really around one particular algorithm, one model in scikit-learn. Can I send it inputs and get back outputs? But another way to think about Algorithmia is if I look at a pipeline, like the sentiment analysis pipeline, and I'll zoom into this image so you can get a better idea of what's going on. So each box here is a separate algorithm in the platform. And you'll notice that some of them are running in different languages. So some are in Java, some are in Python. They all have their own versions. And some of them are running on GPUs, like the OCR tool on the front end. Basically, this takes in documents, OCRs them, identifies the language, translates it to English, vectorizes that, and then generates a sentiment analysis score. So a couple things. Number one, this is used for maybe a PR agency, and we're looking at incoming PRs across the wire, seeing which ones are negative, and I can forward that to the appropriate team to respond to that. The other thing to know is that this looks a lot like a data snippets of microservices without having to worry about all of the plumbing and Kubernetes resources and Docker containers to actually make that happen. The last thing to note here is Algorithmia is aware of these kinds of pipelines. So all this is all just Python code. So if I go into the source code here, you can see where I'm calling a particular model, and I've essentially built my own pipeline within an algorithm itself. So Algorithmia knows this, and it's going to use that information in runtime to say, I'm going to warm up this entire pipeline in terms of which containers are actually running, so it's responsive and not having to wait for each container to start up one by one. So our smart scheduler on top of Kubernetes is doing all of that to make sure that these pipelines are performant and reusable, and again, that they scale down in terms of resources when that demand goes away. So that's a pipelining example. One component that I wanted to mention, in addition to all of the data science and application developer functionality, is the administrator part of this, right? So there is a lot of governance and auditability, traceability going on behind the scenes. So you're able to audit things like who called which algorithm, when they called it, with what data. You're able to go in and look at cluster usage reports, right, and get an idea of some of the metrics, right? So I can look and see what are the different organizations. I can use this for chargebacks and showbacks based on consumption of what's actually being consumed on the platform. You can also think about this as monitoring and alerting. So we measure 90 different KPIs to be able to tell, is the cluster healthy? Are the models working as expected? So all of this means that this platform is for if you're a cluster administrator or a data science lead, you have the information you need to be able to tell how these models are being consumed, if they're healthy, and the ability to audit. So if you need to go back 3 months and see who called this particular credit risk model, what was the data, because we need to confirm whether or not there was bias going on, you're able to track down that level of granularity in our platform. So in summary, let me jump back over here and we'll talk about some of the benefits that our customers are seeing. So the first one is time to value. So we talked about that 85% of projects don't make it past the POC stage, and there's 18 months, the average deployment time. So our customers are moving from that, getting more of their ML projects out there across the organization, used by different lines of business, and shortening down that time to deployment to days or hours, which gives the data science team a lot more flexibility and a lot more focus on the core competency, rather than having to deal with glue code and infrastructure and plumbing to make this all work. The second one is we optimize the productivity of teams. So think of it as letting the data scientists focus on the part that's most important to them, and MLOps and infrastructure focus on the monitoring, the uptime on what's important to them, and not blending the two and overloading certain teams with more responsibility than what's in their scope. The third one is about managing infrastructure. So we've had customers tell us that we've lowered their costs in the cloud by being able to auto scale CPU and GPU workers based on usage. So we want to track that consumption and usage as closely as possible to what's actually being queried and what's actually being asked for, rather than leaving a bunch of idle workers out there that are running models that nobody's calling. So our scheduler and orchestration and auto scaling all takes care of all that, so you don't have to. Finally, we want to help our customers protect their business. So we want to minimize risk by giving you the building blocks that you need for governance, for auditing, for traceability, for all of these models in a consistent way, an urgent way, and a reusable way. So with that information, there's a few resources here that you can follow up on, and I hope you do. The first one is our guide to ML infrastructure. It's a multi-part series that has a lot more details about the different stages I talked about, the infrastructure, the versioning. It's a really great series to read. The other is you can actually try this deployment process that I just showed. You can try it hands-on. So you can bring your own Python model or R model and walk through one of our guides to see how easy it is to build and publish your model in production, as opposed to trying to do all of those steps manually yourself. And finally, you can check out some of our ML use cases on our site, things like image classification, predictions. Try that out. Maybe gives you an idea of some use cases that might map to what you're doing. But thank you for your time. I appreciate it. And please do reach out if you have any questions or think that Algorithmia could help you move your machine learning from development to deployment.